When a system is balanced, we can use the principle of moments to deduce information about the forces in the system. The principle of moments says that a system is balanced when the total clockwise moment is the same as the total anticlockwise moment. And as an equation that can be written, total clockwise moment is equal to total anticlockwise moment. In this example, the total anticlockwise moment is given by force F1 multiplied by distance d1, and the total clockwise moment is given by F2 multiplied by d2. So using the principle of moments, we can say that F1 times d1 is equal to F2 times d2. In your exams, you'll need to be able to identify when the principle of moments should and shouldn't be used during a moments calculation. Let's have a look at an example. Two children, Kai and Jamal, sit on a seesaw. Kai has a weight of 300 newtons and sits at one end of the seesaw, 0.8 meters from its pivot. Jamal has a weight of 400 newtons. Calculate how far Jamal should sit from the seesaw's pivot in order for it to be balanced. So for step 1, let's sketch the seesaw and the forces acting on it. So on one end there's a force of 300 newtons, and that's applied at a distance of 0.8 meters from the pivot. At the other end there's a force of 400 newtons, and we want to calculate the distance from the centre in order for that to be balanced. We can already see that Jamal will need to be closer to the pivot to keep the seesaw balanced, as Jamal weighs more, so needs to be a smaller distance from the centre, otherwise the moment will be larger. For step 2, let's calculate the moment caused by Kai's weight. The moment is equal to the force multiplied by the perpendicular distance, so in this example, the moment is equal to 300 newtons multiplied by 0.8 meters, and that is 240 newton meters. For step 3, we want to deduce the moment caused by Jamal's weight. So we know that the principle of moments applies here, so the moments must be equal. So we can say that Jamal's moment is equal to Kai's moment, which we've already calculated to be 240 newton meters. For step 4, let's rearrange the moment equation to make distance the subject. So we can do that by dividing both sides of the equation by force. The equation then becomes moment divided by force is equal to the perpendicular distance. Then in the final step, let's substitute the values to calculate the perpendicular distance. So here we've simply flipped the equation from the previous step, so the perpendicular distance is equal to 240 newton meters divided by 400 newtons. So the perpendicular distance is 0.6 meters.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!